Hello and welcome to the fourth day of parametric functions. Today we're going to start with some radio-controlled boats. Three people are playing with their radio-controlled boats, and each boat is moving at 4 feet per second. So this boat A, if I wanted to write the equation for it, it's going to move 4 feet per second, so we're going to go 4t. Since we're going to pretend like this is the x-axis. So it's going to start up 10 in the y direction, but it's going to be on 0 in the x direction. Boat B is going to start 25 feet to the right. So it's going to start 25 feet to the right, and it's going to go to the left 4t, 4 feet per second. And it's going to be at 5 feet in the y direction. Now boat C is going to start 5 to the right, and it's going to go up 4 feet per second. So we could fill out the table, and this is what the table would look like. The x is going up by 4, the y stays the same. Here the x is going down by 4, the y stays the same. Boat C is staying constant at 5, but the y is going up. Now if we change this so that there's a wind blowing from west to east at a constant rate of 3 feet per second. So it's moving from west to east 3 feet per second. Let's see how this changes it. Boat A is going to start at 0, 10, but after 1 second, it's going to go 3 feet per second further. So it's going to be at 7:10. Then it's going to go to 14:10 and 21:10 and so on. Now boat B is going to be going this way 4 feet per second, but the current's going to move it, or the wind's going to blow it back 3 feet per second. So it's actually going to go only 1 foot to the left every second. So 24, 23, 22, and so on. Boat C starts at 5, 0, and if it goes 3 to the right and 4 up, it's going to be at 8, 4, and then 11, 8, and so on. So if I wanted to write some equations for this, this is going up 7 per second, so that would be x equals 7t. This is going to stay at 10. Now this x is going to be starting at 25 and going down 1 each time, so 25 minus t, and the y stays constant at 5. Boat C is going to start at 5 and move up 3 each time, and y is going to be going up 4 each time. 0 plus 4t, I could have just said 4t. So all this has changed. All what's changed is just the x equation has a 3t added to each of those values. All right, so how far does boat C travel in the first 3 seconds? Well, it's going to end up going like this, which will create a triangle. We actually don't need the triangle until the next thing, but it goes from 5, 0 to 14, 12. So this is 5, 0, and this is 14, 12. So in the x direction, it moves 9, and in the y direction, it moves 12. So if we have 9 squared plus 12 squared equals c squared, that's 81 plus 144. That's going to be 225. And square root that, and it's going to be 15. Now if you knew your Pythagorean triples, this is a 3, 4, 5 triangle multiplied by 3's. So it's going to go 15 feet, and it does that in 3 seconds, so its velocity is 5 feet per second. So at what angle with the bottom of the pool does C travel? Well, here's the bottom of the pool. So that angle is going to be, you can use tangent of theta is 12 over 9. So I just do the inverse tangent of 12 over 9 to get the value of 53 degrees. All right, so now if we start in Albuquerque and we fly due west, or we start in Memphis, and we fly due west, uh, but we don't take into account the 20-mile-an-hour wind from the north. Let's think about these equations. So my axis starts here. My x, I'm going to the left, so that's going to be negative 250 t. Now, my y direction is going 20 degrees from the north, miles per hour from the north, so it's going to be blowing us down 20, 20 miles for every hour. So if I just decided to head straight west and not care about ever recorrecting and aiming towards Albuquerque, what would actually happen is in 4 hours, I would be 1,000 meters to the west, but I would be, or 1,000 miles to the west, but I would be 80 miles, because 4 times 20 is 80. I'd be 80 miles to the south. So I wouldn't hit Albuquerque if I just flew straight west. So how far did the plane actually travel in 4 hours? Well, let's take a look. They went 1,000 miles to the west, 80 miles down. It actually flew 1,000 squared plus 80 squared equals c squared. So 1,000 squared plus 80 squared is 1,066,400. Now if I square root that, it actually goes 1,003 miles. 0.2, maybe we can say. So if this is 1,003.2, 1,003.2 miles, that's how far it traveled. So if I want to find the ground speed of the plane, what the plane did was that over 4 hours. So divide this by 4, and I'll get 250.798 miles per hour. So just a little bit faster than what it said. What is the bearing of the plane's actual path? Well, if we take a look at this, the bearing is going to be this. So I just need to find out that angle and then subtract it from 270. So I'll do the inverse tangent of 80 over 1,000. So inverse tangent of 80 over 1,000 to get 4.5, so about 4.6 degrees. So take that from 270, 270 minus that answer, and it's about, the bearing is about 265.4. Now, at what angle and bearing should the pilot fly to actually reach Albuquerque? All right, now this is a more difficult question. So he wants to aim this direction so that this force counteracts that force going down at 20 meters per second. Because when those two interact, then it will be flying due west. So what we'd have to do is have 20 there, 1,000 T there, or 250 T. And to find this angle, would be the same thing, which is the 4.6 degrees. So what the plane actually has to fly 4.6 degrees above east, or I'm drawing it in the wrong direction. What am I doing? It's actually going this direction. So he has to go 4.6 degrees above that in order to counteract uh, the the wind. So it's going to be 274.6 degree bearing. Now, how long will it take to fly to Albuquerque? Well, if they're going to continue going at uh, 250 miles per hour, and then uh, in the y direction, we're going to go up 4.6. All right, so as I was talking about us going in the x direction 250t. Now we're not going exactly 250t in the x direction, we're going 250t up here. So to figure out how far we're going in the x direction, what we'd actually have to do is do the cosine of 4.6 is equal to our x value over 250t. So really it's 250t times the cosine of 4.6. Now in the y direction, we should just be going straight west, so that will be 0. So if I multiply this out, 250 times the cosine of 4.6, that'll be 249.2, 249.2 t. So if you want to see how long it's going to actually take to get to Albuquerque, well, it's going to be 1,000 equals 249.2 t divided by 249.2. So 1,000 divided by our answer. I did one too many zeros. Will give us 4.01 hours. So just a little bit longer than it would have taken if there was no wind. All right, that is the rest of the lesson. So have good luck with the homework.